Okay, I'm stepping into talking about something that we haven't really addressed yet, and it's got to do with I've been talking about area under the curve when you integrate that sort of thing. Um, but the area under the curve, I want to show you that I put quotes around it on this. I've got the iPad going here, and I've got quotes around the word under because of the fact that if you're taking the area, we're calling this straight line a curve, the area of this curve under the curve, it's talking about under the curve to the x-axis, okay? So the area, when we're over on this side, that's obvious. When we're over on this side, you've got the area, this is the area under the curve. Well, in reality, we're talking about the area between the curve and the x-axis. So on the left-hand side of this, where it intersects the x-axis, notice it's not under the curve. The graph itself is below the curve, so it's above the curve. It's between the curve and the x-axis. And it turns out that when you get an area under the curve, it turns out to be a negative value. So let's take a look at this. Let's do the math of the situation right here. This is at 3. The height is 3. And I've got the triangle. So the area of a triangle is equal to 1/2 base times height. So we've got the area of this top triangle up here is going to be 1/2. The base is between 4 and 10, so that's 6. And the height is 3. So we end up 1/2 of 6 is 3 times 3. We've got 9. So the area inside this region here is 9. All right? So let's see what the area, let's do it on our calculator. If you have your calculator with you, look at, I've got the TI going here, and I'm going to go ahead and do an integral. I am going to do this problem right here. The integral, and I'm looking at the area under the curve. Well, I figured out what this was. The y-intercept is -2, so b is -2, and the slope is, I have to go to the right 4 up 2, so change in y is 2. M equals change in y over change in x, up 2, right 4, that's equal to 1/2. So we end up with y equals 1/2 x minus 2. That's the equation of this line right here, okay? So if I want to find the area under the curve from 4 to 10, find the area of that triangle, then I'm going to do the integral from 4 to 10 of 1/2 x minus 2. And it's always a critical factor. We got to remember the dx. That's the width. You know, it'll play something even stronger in this Calc 2 section. You'll make sure you're conscious that that's a critical part of a correctly written definite integral. And this is definite because you've got endpoints, 4 to 10. The answer to this is a value. If it's an indefinite integral, there's no numbers here, no a and b, then your answer is going to be a function, and you pretty much need to add c every time, plus c. But in our situation, we've got this definite integral, and we're going to now plug it into the calculator and get our solution. Next week, we're going to be talking about the fundamental theorem of calculus, where we'll be calculating this number by hand. And you using the calculator will just be a verification, check to make sure your answer is right. But right now we're going to plug it in. So I'm going to go to, if you get your calculator out, go to make sure you clear your screen. And if you would, go to math, hit the math key, third one down there under the y equals, then you got 3 keys down, it's math. And go down to 9, go down to the number 9, and notice what's there, FN INT parenthesis, all right? If you got a TI-84 and you hit enter here, you'll get an integral symbol. You'll get an integral, and you have a box down at the bottom for a, where the 4 is, and a box up there for 10, and a parenthesis in there for the function, and a D with an empty space after it. If you've got a TI-83, you just have on the screen FNINT with an opening parenthesis, and it's looking for right now, plugging the function in. So 1/2 x. I'm going to put 0.5x. That's what I've got in front of me right now. 0.5x. I've got this in TI-83 mode type thing. That's 1/2 x minus 2. All right, then you need a comma, and it's going to be in terms of x. So those of you that have a TI-84, inside the parenthesis there, you'll have 0.5x minus 2. And then afterwards, there's a d with a little box, and you put the x in that box after the d. That's your dx, all right? And then on the TI-83, I need to put the value of a, which is 4, and then comma, 10, close parenthesis. If you've got a TI-84, you stick a 4 down there at the bottom of that integration bar, and a 10 in the top, and then you've got the function in the parentheses and dx afterwards. And hit enter, and we'll get the same exact answer. Turns out to be 9. Let's verify that. 1/2, we got that already. Area of 1/2 base times height we got is 9. That area is 9. Now, let's do the same thing with this side over here, okay? So this is going from 0, it's the same function, 0.5x minus 2 is the line, but it's going to be from 0 to 4. And let's get the area of this. Let's see, the height is 2, the width is 4. So area equals 1, this is the left side, I'll call that a sub 1, this is a sub 2. 1/2 the base, I'll call 4, the width, times the height is 2. Therefore, that's 2 times 2, which is 4, all right? So this area down here is 4, but it's under the x-axis. Therefore, in the calculator, it will be read as negative. So let's do the function again. Let's do math. Get your integral screen up, math 9, FNINT. The function is 0.5x minus 2. And notice that it's going from the a and the b are 0 to 4. So I've got, on mine, I've got 0.5x minus 2, comma. X goes next, and remember, after the d comes the x on your TI-84s. And then I've got comma, and the a is equal to 0, and the b is equal to 4. So 0, comma, 4, close parentheses, and hit enter. Okay, and what do you get? Do you see the minus 4? The minus 4 comes from the fact that it's 4, the area is 4, but it's under the x-axis, therefore it is negative 4. So if you were asked, if this was an area question, the negative area doesn't make sense. But 4 would be the area, but it's under the x-axis, so negative 4 is the situation here. So let's do this problem one more time, and this time do the same function, but go from 0 to 10. Do the whole thing. So I'm going to do, again, math 9, and then I'm going to plug in the function, 0.5x minus 2, comma, x. And for those, again, with the TI-84, put the function and the x after the d. And then you need also, you're going to go from 0 to 10 this time. So it's 0, comma, 10 in parentheses. And what should we get? We got 9 minus 4. The answer should be 5. You see that? We've got that. So I ended up putting this last time. I put this in here. And I got 5. All right? So what we did the second time was 0 to 4, 1/2 x minus 2 dx, and we got negative 4. And you put these two together, and you get the sum total, all right? So the area under the curve is negative, under the x-axis, excuse me, is negative, but the area under the curve between 0 and 4, notice it's not under the curve. It's between the curve and the x-axis. So that's an important thing to make sure you get down, right? So take a look at that. If you want to look back over this again, feel free. This is an important factor in doing the calculations that get you above and below the x-axis, okay? So that's it for now, and I'll talk to you a little bit downstream.